Hey folks, this is the last video in chapter 1 of Unit C. So this is the last of electrical energy, talking about the concept of the kilowatt hour and electrical cost. Like, how much does electricity cost? When you check out your power bill of your household, you're not going to see the amount of electrical energy that your house consumed measured in joules. It's just not going to happen. The way that consumer electricity is measured is using a different unit called the kilowatt hour. And I'm going to show you two ways to kind of express a kilowatt hour, talk about what it actually is, then we'll do some really quick calculations with respect to cost. So yeah, I know we call EPCOR a power company, and we say that it's our power bill, but I gotta tell you, you're not buying power. You're buying energy. So how do we figure out what a kilowatt hour is? I've got one such conversion here. If you want to convert between kilowatt hours and joules, it's 3.6 megajoules is 1 kilowatt hour. So if you wanted to make this into a conversion bracket, let's see, 3.6 million. So that's 3, then a 6, and then 5 zeros. 1, 2, 3, 4, 5. 3.6 million joules in 1 kWh. The other, of course, would be with the numerator and denominator flipped. So 36,000,000. Still, remember the number and the unit are like joined at the hip. They don't go anywhere. You can't separate them. And so that's 1 kilowatt hour is 3.6 megajoules, or 3.6 million joules. So that's the easiest conversion that we can do. But the real simple one is, or the one you're going to have to do a little bit of work with, it's very simple. Oops, get your power. Two. There you go. So you get your power into kilowatts, you get your time into hours, then you multiply them together. So simplest kind of example question, let's say let's make it a non-nice and rounded number. Oops. Not 350 minutes. If you're nuking something for that long, I question your cooking skills. Okay, so microwave uses 1100 watts of power. You run it on high for 35 minutes. How many kilowatt hours? All right, so I have it in watts and minutes, and that ain't gonna cut it. I need to turn this into kilowatts and hours. So remember, a kilo of something is 1,000 of something. A kilogram is 1,000 grams, so a kilowatt is 1,000 watts. So I need to first convert my power into kilowatts. Easily done. So here's 1,100 watts, and I convert. There is 1 kilowatt, and that's 1,000 watts. So our math is going to let us get rid of watts as a unit, but it's okay because we still got kilowatts. And remember, that's the whole point, is to turn this into kilowatts. So we have 1.1 kilowatts. Then we have to get our time into hours. Okay, so I know because I am just a super genius, that our incoming unit is 35 minutes, and we have to turn it into hours. So I know that there are 60 minutes in 1 hour. Remember how the math works. We multiply by the top number, then we divide by the bottom number. So 35 times 1, that doesn't do anything. Then we divide by 60 and we get 0.583 hours. And then, regrettably, that's a repeating 3. What I'm doing, though, I'm not going to round this yet. I keep the number in my calculator. Remember, the only time you round is at the very, 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 very end. So let's see how many kilowatt hours this is. So we take our kilowatt number and we multiply by our hours number. This is like absolute cake. 0.583 hours. So I'll just multiply the number that I got by 1.1, and we get 0.64 kilowatt hours. And I've recorded my answer to 2 sig digs. I kind of did the rounding just looking at it. So let's do another question. Let's do one that has megajoules. It has to convert into kilowatt hours. Well, let's make it a little bit more challenging. Let's say I shouldn't say AC because that sounds like alternating current. All right, so a little bit more difficult. An air conditioner in Phoenix uses 6.2 megajoules of energy and is rated at 2,000 watts. And I'm going to put a 0.0 on here just so we've got sig digs. Because if I just leave it at 2,000, that only has 1 sig dig. How long was it operating for? So we're going to have to get this into a time. Let's say in minutes. So megajoules doesn't have any time in it. So what we need to do is turn this first into kilowatt hours. So let's do that exact thing. So we have 6.2 megajoules, and we need to turn that value into kWh. So I go up to my conversion, and it's 3.6 megajoules is 1 kilowatt hour. So I say 1 kilowatt hour is 3.6 megajoules. And incredibly, megajoules is toast. The only unit that's left is kilowatt hours, which is what we want. So 6.2 divided by 3.6. Gives me 1.72 repeating kilowatt hours. Remember, I'm not going to fiddle with this number. I'm not going to round it yet. So if you think about it, kilowatt hours is literally kilowatts times hours. So if we know the watts and we know the kilowatt hours, I can simply do this. 1.72 repeating kilowatt hours, and we can divide by the kilowatts, which is 2.00 kilowatts. The super smart of you are going to notice that if we have kilowatts on top, we got kilowatts on the bottom. Hey, look, they cancel out. And all we have to do now is this little division. What is that going to give us? Time in hours. All we got to do is multiply by 60, and we have time in minutes. So I'm doing the math, and we get 0.861 hours, so 0.86 repeating 1 hours. And I'm still not done, so now I'm going to convert. And I know there are 60 minutes in 1 hour. So I multiply this number by 60, and I get 51 point repeating 6 minutes, but I only have 2 sig digs to spend, so I will say 52 minutes. So this is kilowatt hours in a nutshell. Very, very simple calculations. Convert your power into kilowatts, convert your time into hours, multiply them together, boom, you got a kilowatt hour. Or if you're given megajoules, turned into kilowatt hours by dividing by 3.6 million. The last thing is cost. So let's say there we go. So a fridge is consuming 1.4 kilowatts of power. It's operating for 7 hours. I made these in kilowatt and hours just, because we don't want to do a whole bunch of extra math. We just want to go straight ahead. How much does this cost if electricity is 6.3 cents per kilowatt hour? So when I see a per, I'm going to say 6.3 cents per kilowatt hour. It's like miles per hour or kilometers per hour or grams per mole. These are just combined units. So first of all, my power is in kilowatts, my time is in hours. So quite simply, 1.4 kilowatts multiplied by 7.0 hours. Then I'm going to multiply by 6.3 cents per kilowatt hour. Because look at what's going on with the units. Kilowatts on top, kilowatts on the bottom, goodbye kilowatts. Hours on top, hours on the bottom, goodbye hours. So when I do the math, all I need to do is multiply all those numbers up top together. That's going to give me my cost in cents. Might you have to convert it to dollars? Yeah, you might. So 1.4 times 7 times 6.3 is 61.74 cents. So since we are only doing 2 sig digs, that means I'm going to round it to the nearest 2 sig digs. So we'll say that running this particular fridge for 7 hours is going to cost me, 62 cents. So again, all you do is multiply the kilowatt hours by the cost per kilowatt hour. Your kilowatt hour cancels out, and your cents is going to be the only thing that remains.